So, good evening, guys. Welcome to our session in here for today. I hope all of you guys are doing really good, and I hope all of you guys are able to hear my voice clearly. My screen is also visible, right? Can I get a small confirmation for this by any one of you guys? Whether I'm audible, whether my screen is visible, and whether everything from the internet point of view is going good. Guys, can I get a small confirmation for this? So let us get started with the portion that we have discussed over here. So thank you for the confirmation. Everything is going good. So you can take a minute of your time to go through the steps that we have discussed over here. So basically the steps that are present over here, these steps can give you a really good idea about what you should do in your project work, right? Or what you are expected to do in your project work, right? So these basically are some of the things over here that can definitely help you in getting an idea about a lot of portion, about a lot of things over here. So take 2 minutes. What basically happens over here is that you have to import important libraries. You have to get an understanding about the data with which you are working, right? There are basically a lot of things over here that can help you in these stuffs, right? So importing important libraries, then importing the data, then getting an understanding about the data with which you are working, right? Best getting an understanding about the business problem that you guys are kind of trying to solve. Then doing a detailed EDA, because the detailed EDA is basically something that is expected to give you an overview, or that is basically something that is expected to give you an idea about the work that you are kind of expected to complete over here. After that, there is approximate patterns. So that detailed ETA will give you approximate patterns, and those approximate patterns are basically something that you can definitely take into consideration to get an idea about the given portion or idea about the given part over here. And after that, you can do pre-processing for those ML algorithms separately. You can perform train test split. You can evaluate the predictive performance of the model with the respective portion that you are kind of planning to evaluate it for, right? So there are basically a lot of things over here that can help you in getting an idea, getting a really interesting idea about the sections or about the portions that are available over here. So you can take 2 minutes of your time, and then we can move ahead with the next portion over here. Right, 2 minutes of your time, guys. Take your time for going through this workflow. So after this particular portion or after this particular workflow is completed, let us try to go through the portion, or let us try to deal with the given section in detail, right? So this is basically the workflow. Now, after this is done, today we are going to have a detailed discussion about ANN and CNN, right? Object detection projects. So the main topic of yesterday's session or the previous session on Tuesday was web scraping and ML, traditional ML algorithms. Today it is deep learning, ANN, CNN, object detection. So let us see what projects are there. So it's the first project itself, right? So let us try to see how this project can definitely help us in getting an idea about the given sections or the given portions over here. So it's 1078, right? Let's move ahead with 1078 over here. So in 1078, basically you can see that this is the description, and basically there are 1 million Sudoku games project that employs deep learning algorithms, specifically ANN, for classification task related to this. So here you will have that data set and you are expected to find the missing numbers. You are expected to create a model to predict and fill in the missing numbers in the Sudoku grids accurately, right? So this is a really interesting problem that you can take a minute to go through. You can read it, you can understand it. And whatever we have completed in our workflow, all of those things are really important for us to like complete it. So take your time for this and do let me know if you are having any questions, doubts, concerns that I can help you with. So this Sudoku one is like a really great project, and I mean, if you are able to solve this level of projects, then it can definitely help you in getting an idea about a lot of interesting concepts over here, right? Actually, it can help you in a lot of sections, in a lot of portions. Now here you can get the data. What is the ID of this particular part? 1078. So let's go over here, right? And in Blackbucks projects 1078. So this is basically the data. This is basically the Sudoku data that you are expected to move ahead with. It is like a really big amount of data. So for that reason, it may take a good amount of time, but it is very interesting for you to make a note of it. Now, after this is done, you can see that these are the quizzes and these are the solutions, right? It's just the quiz and the solution, quiz and the solution. And from that, you can create a model. After that, let us have some interesting portion over here. Baseball, exploratory cryptocurrency, character recognition. I think this is very interesting. Character recognition in natural images. What is it? 876. So let us try to move ahead with that 876. So what basically happens over here is that you will get these many different images. Like you can have a look at the images. This is image number one, right? Like that you can have a look at all the images that are present over here, right? So in this image data, right, in this image data, you are basically expected to identify the digits. So it is a multi-class classification problem over here with which you guys are kind of expected to work. So this basically tells that which image is which digit. This is the label, right? This is the label that is kind of associated with respect to that portion, right? Everybody, guys. So you can take the note of this particular data, and the most important thing is like let us go and let us read the description of the data, right? 1, 2, 3, 4, 8, 76. So in 876, it is a computer vision problem, and you can get an overview about it. It is character recognition in the natural images that are basically present over here, right? So this indeed is like a really effective problem over here with which you are expected to work with. Take a minute to read about this. You can use CNN on this problem. It is a perfect problem if you want to practice CNN, anything related to CNN, right? Thirty seconds, guys, on this, you can get an overview about the given part. And in this algorithm, as I told you, CNN convolutional neural network is one of the typical algorithms that you can aim to apply. Now, after this is done, just give me a minute. Done. Nalindini is saying done. Perfect. So basically, you can get an idea about the data with which you are working over here, right? The data is basically something that has been available, given over here, image data and the labels, and then you can have the files, right? So there is a Jupyter source file that is available with me, which can give you an overview about what can be done, what could be one of the possible solutions or one of the possible metrics over here, right? So these basic portions are something which definitely will have a huge impact on the portion that we are kind of trying over here. So they are importing all the important libraries, right? Then you can specify the directory, get the files, right? Get all the images along with their labels over here, right? Then the next part over here is that you will scale that image divided by 255, right? Print the length. There are 3410 images, 3410 images in total are there. Just imagine that much amount of data. Imagine how much amount of time you will have to work around with, right? So that is basically something with which you guys are expected to move ahead with, right? Everybody, guys. Now, after this is done, the next portion over here is that you will print the shape, you will import them again, you will have that data in the form of multi-dimensional NumPy arrays. And once that section has been employed over here, then we will kind of try to move ahead with really interesting sections over here, right? Now, after this particular section is done, the next portion over here with which you are expected to work is that here they are framing the architecture of the neural network. See this architecture, they are creating a sequential LSTM model over here. And with the help of that, later on you are adding LSTM layer followed by dense layer, then you are compiling it. And finally, you are getting an idea about when you explain LSTM layer, it is long short-term memory, and I think it is covered in detail in this session. I gave you a document also for LSTM. Right in day 20 and day 21, there is some explanation about LSTM Nalindini that you can find. Right. So I will recommend you to go through the recorded sessions for that because it's not possible to explain that in short. In that recorded session, I have explained it. You can definitely go through this, and tomorrow's session is the final session. So definitely your doubts are always welcome, right? Now, after this is done, the next part over here is that it will try to get an idea about accuracy and everything, and you can compile the model, train it. It's very big. I mean, this is just one of the possible solutions. There are multiple solutions that are available over here. But this character recognition, this one in natural images, this is actually a very interesting problem that is kind of available over here. And I will recommend all of you guys to definitely go through this particular part if possible, right? Now, after this particular section is done, the next one, let me see which is the next one. NLP is there tomorrow. Click with this is still done earlier. NLP is again tomorrow. Customer journey date. Deep fake prediction, synthetic media, and this is very interesting. 872. So, if there is a given news, you are expected to identify whether the news is real or fake. This is a very interesting project, right? So 872. So in this particular project, deep fake detection, you are basically expected to identify whether a given news that is present over here, whether it is real news or whether it is fake news. So take a minute to go through the brief description about the problem that is available over here and let me know if I can help you with anything. So I will also walk you guys through the data. The data is actually very interesting, right? The data with which you would be working, it is actually very interesting, very, very, very interesting. Now, after you guys have read this particular description of the problem statement, this particular portion is definitely something that can be very useful because a lot of times nowadays, because of Fake news, a lot of people, especially in stock market, they are trying to manipulate the market, right? And definitely this type of algorithms are coming into picture. So rising concerns over the creation and of manipulated media, right? So for this particular portion, you guys are expected to pick up the data from Kaggle, right? Kaggle is basically the source from where you guys are, what you can say, kind of expected to pick up the data. And then we would be moving ahead with the next portion over here. So now after this is done, let us try to see how the how the data is looking, right? Because the data for this was not available when I saw it. So let us go in the data set. And here the data is something that you can extract from Kaggle, right? So this is basically the Kaggle data. This is the, uh, what you can say, there are videos. This is a video data, right? And you can then submit a CSV file, which looks something like this. Let me download it and show it to you how the data is. So was it downloaded? Yes. So deep fake challenge, and now the data is available over here. It is 4.4471.84 GB long zip files, right? So if you work on this project, it is gonna be very computationally very expensive, but like if you can do this project, then definitely the kind of value that you can add on your resume, it's unmatched. Honestly, it's unmatched, right? So now after this is done, synthetic media, this one is done, diabetes detection, dog and cat image classification, very interesting and very typical, right? 865 is something that we have to see. So this is the problem statement 865. In that 865 one, there are images, and those images are either the images of cats and dogs, and you are expected to create a classification problem. As this is image data, CNN is definitely something that can turn in very handy, right, for all of you guys. Correct, everybody? Are you clear with this? Now, after this is done, by the way, take a minute for this and let me know if I can help you with anything or not. So now after this is done, let us try to 865. Let us try to see the raw data over here with which we are working. Right? Let us try to see 865 raw data. I hope I'm having raw data for 865. Okay, so raw data is not basically present over here, right? And I think I will have to take the raw data from the portal. I think the raw data for this again is available from Kaggle itself, right? Data set, input, and then this data is available from Kaggle only. So the input data is basically the images, right? And ResNet is something like image data is very expensive, computationally very expensive in size and everything. So CNN with transfer learning is something that they have employed over here. Again, something which is very valuable in your profile, to be honest with you. So whatever concepts that are basically available over here, those projects are very valuable. Whatever gets allocated to you, then I think that these things are something that would be very handy, that would be very helpful. Okay, so you can, one is dog, zero is cat. You can take this link and you can basically identify the data as well, right? Now, after this is done, let us try to see the next project that we are having. Electricity, this is time series one, extract text from images, OCR problem, optical character recognition, 885. So you can get an idea about extract text from images. You read the description. So there is image data, and in that image data, there is some text that is being written over here, and it is kind of your aim, or it is kind of your responsibility to extract whatever is the textual data. So it covers NLP and image data both. It covers the principles of both the things. Take 30 seconds for this and let me know if I can help you with anything over here. So now after this is done, could you please explain about OCR? OCR is optical character recognition, which basically means that, let us say that if I have some image data, let us say that this is an image, and there is something that I wrote, right? There are a lot of images. There are images of nameplates. The best example is, let us say that you are working for the transport department of the country, and you are expected to create a predictive algorithm, or you are expected to create an algorithm such that if a person is breaking the traffic rules, you should be able to read the characters that are available on the nameplate, right? You should be basically expected to read the vehicle number and punch in a challan for that particular vehicle. So that is coming under OCR, optical character recognition problem over here, right? Is this clear, guys, to all of you? Right? Murtuza Sayed, I hope this answers your question. So that's optical character recognition. Whatever characters are available, you are expected to detect that with the help of this particular portion. And let's try to see the data now. Let me see if I have the data 885. The data is not available over here. So uh, again here we will have to scroll, and I think the data would be taken up from the Kaggle. Right, so I can go in the source code input, and I think the data would be available over here. You can also read about what they have exactly said over here with regards to the problem statement, right? So this is the problem statement, handwriting data set. I can also give the link, and I think you should spend 2 minutes in exploring the given Kaggle website that is present over here. Right? Take your time, and obviously, if you have any questions, like Sayed has asked me, Nalindini has asked me some questions. So your questions are always welcomed, guys. If you have any questions or any doubts, do feel free to let me know about it so that I can explain that one given topic to you in detail. Now, after this is done, after you guys are kind of clear with this, let us then move ahead with the next example or next problem statement. So after this is done, let us try to see what we can do now after this. So let me close this particular portion and let us see what is the next project over here. Facial gender recognition, very interesting. So you will have images of different male and female candidates, and from the image you are expected to identify whether the person is male or female. Very interesting project. So 862, let us see what is there in this particular project. You can use CNN since there is image wherever you will see image data in all of those places you can use CNN. That's something that you can make a note of, right? So now here you can take a minute of your time to read what is the project, right? And how you are expected to solve it. They have also explicitly told you the method which they are expecting you to use, right? So it's not that you can use any method or any deep learning algorithm. They have specifically mentioned over here which method or which portion you are expected to kind of complete. So, right, I hope you got the description about the problem statement. And I personally feel that the data would be available on Kaggle from the source is Kaggle, right? And again, since this is image data, the size of the raw data would be very expensive because you will get the images over here. And then you guys would be expected to identify whether those images are belonging to what you can say male or females, right? So now after this is done, let us try to scroll and see the data. I think it's also input. And now this is the link of the data from where you are expected to extract that particular part, right? So 1.41 GB, huge data. And obviously this is something that can come very handy. What is VGG? It is the architecture of CNN, older architecture of CNN. So you can take a minute of your time, go through this, and let me know if there is anything that can be cleared over here. And now after this is done, let us try to see what is the next project that is available. And after this is done, let us try to see the next project over here. So facial landmark detection, precise facial feature localization. So I think YOLO algorithm is something that you will have to use over here. Because there is object localization. What is object localization? We have dealt with object localization in this part, right? Object detection and object localization. These are two different things. Detecting an object and locating where that object is located. These are two really different portions, or these are two really different things over here, right? So you are expected to get an idea about this particular portion, everybody, guys. So take 30 seconds of your time, read about this, and let me know if I can help you with anything over here. Now, after this is done, obviously the data for this cannot be kept in the local drive. It is very expensive. And that is the reason we would be moving ahead with Kaggle again. So on the Kaggle portal, you will basically get the data. Now, after you have understood the brief description of this particular problem statement, right? Let's try to see the Kaggle source over here. You can get some idea about what is the problem statement. And this will require, I'm thinking it will require YOLO. You only look once, right? It's an object detection problem. I think YOLO is something that you will have to move ahead with. So take 30 seconds of your time, go through this, and let me know if you are having any questions, doubts, or concerns with which I can help you. So we can go over here at the bottom and we can choose the right data set. This is the link for the input data, right? And facial key points.csv, there are images, like there is image data as well as there is a CSV file. You will have to merge the labels, and from that, I think you will get an overview of exactly how you are expected to move ahead with these portions, right? And now after this is done, the next portion over here with which we would be working, let me see the next project, facial recognition based attendance management system. Okay. So in a particular lecture or in a particular session, you will revolve the camera, you will see who are present, and from that you will analyze whose attendance should you mark or not. 831. Really interesting project. So you will have that which face is belonging to which roll number or which ID, and from that attendance would be marked. Really interesting. So you can take up this particular project and let me know if you are having any questions, doubts, or concerns with which I can possibly help you. So take an overview of this particular problem statement. And you can then take some of your time to read about this particular data set. Right, I think the data is already available over here. What was the project number? 831. I think then I will have it. 831. So it is basically the zipped data, and this is basically the data that you are expected to move ahead with, right? So basically what is happening over here is that you can see the data will open up. It is the image, the gender, the background, right? And roll number. As I told you that according to roll number, there would be the mapping that is available over here. right? So that is definitely something that you guys can take into consideration over here. Take a minute, go through this particular data. This is basically the important data that is kind of present over here. And with this data, you are expected to move ahead with the next one. Sorry. And after this is done, there is, I think, the automated attendance system over here. So this automated attendance system is also definitely something. So this is the abstract. The traditional method involves calling out the number. There is proxy issue and everything. So to handle that, this problem is kind of present here. So take your time, go through this and let me know if I can help you with anything over here. And now after you understood the problem statement, the next portion over here with which you guys are kind of expected to move ahead with, it is basically about the data, right? So for this person, what is the name, roll number? You can directly detect his face and mark the attendance, right? That's the power of CNN, right? It's a very interesting project, by the way, to complete. Then FIFA analysis, fruit recognition. So different types of fruits would be classified over here, 886. You can read the description. I think there are multiple images of different fruits, and the ultimate aim over here is to identify different fruits that are basically present over here. So you can take a minute of your time to read the abstract. Basically, in whatever problems we have discussed today, the most important thing that is addressed over here is CNN for image classification. So you should be very clear with the concepts of CNN, and you should also be in a position that you can frame the architecture of that neural network over here. If that is something that you can do, then I think you can move ahead with the next portion, next section as well. And now, after this is done, they have given that how it can be used in agriculture industry and whatnot over there. And here is the input link, right? So you can take a minute to go through this. Using RESTnet, you can do that particular portion. So there are 82,213 images in training testing. There are 120 fruits and vegetables in total. Image size is 100 by 100 pixel, right? So these are the fruits. 120 fruits are there. So that level of algorithm is something. 120 classes are there in the target variable. So this is something that you are expected to understand and move ahead with. So now after this is done, you can get the properties of the dataset over here. How many classes are there? Like every bit of detail with regards to this portion. And now after this is done, the next project that we are having for discussion, GoDaddy, insurance, image face counting for object detection. Let's see what is in here. 881. That's the next project. In 881, you will be able to get the image face count. So in a given images, how many faces are available? That is something that you can identify. So take a minute, go through this, and do let me know if I can help you with anything over here. Another thing, tomorrow's session is the last session. So if at all you are having any questions or doubts, just make sure that you are interacting with me for that by tomorrow itself, right? And obviously the data for this is available on Kaggle. Obviously, I will not have the data for this. It's very big. So you can take a minute of your time and you can go on Kaggle for the given link, and basically in the description they give you the idea that where that particular data set can be used, what are the uses and everything, and this is the link that is available for Kaggle. YOLO version 5 is expected to be used over here, right?